Hello everyone. Today, through this PPT, I would like to tell you something about combinational circuit, which is one of the most important topic of digital electronics. Combinational circuit, first of all, we will see what do you mean by combinational circuit. So combinational circuit is basically consists of logic gates whose present output is dependent on present inputs only. So if you are having n input variables, there will be 2 to the power n possible binary input combinations. And for each binary input combinations, there will be one possible output. Combinational circuit can also be described with the help of truth table that will list the output values for each combination of input variables. So if you are having m Boolean functions for each input output variable, from the logic diagram, from the diagram, it's clear that combinational circuit consists of n inputs corresponding to m outputs. Next, we will see what is the difference between combinational circuit and sequential circuit. So for combinational circuits, already I have defined that it is a type of circuit which is having m inputs, and or we can say that outputs or output of combinational circuit is dependent on present inputs only. But a sequential circuit is little bit different from it. Sequential circuit consists of a combinational circuit along with storage elements, which are known as memory elements. Because the output of sequential circuit is dependent on present input as well as past output. And to store that past output, you need some storage elements, which is known as memory elements. And flip-flops are mostly used to store past output in case of sequential circuits. Next, we will see the combinational circuits one by one. The best example of combinational circuit, or we can say that half adder is one of the combinational circuit which is used for the addition of two binary bits. Name itself indicates it is an adder, and since it is a half adder, so it is used for the addition of two binary bits. So for the addition of two binary bits, you are having two input variables, and since you are performing addition, so two outputs will also be there according to the rules of binary arithmetic, which we have already seen. So for the addition of two binary bits, you will have four combinations because 2 to the power 2 is equals to 4. So we'll see from the truth table that A and B are the inputs and sum and carry are the outputs. So when you will add 0 plus 0, you will get sum is equals to 0 and carry is equals to 0. When you will add 0 plus 1, sum will be 1 and carry will be 0. When you will add 1 plus 0, then sum will be 1, carry will be 0. 1 plus 1, sum will be 0 and carry will be 1. Now you are having truth table, and we are already familiar with the mapping process of K-map. How? So we'll solve the equations for sum and carry utilizing two variable K-map, since we are having only two inputs. So we'll use two variable K-map 0, 1. We'll put the inputs as 0 A and B, 0, 1, 2, 3. So first of all, we will solve for sum. So we can see that sum for the outputs we are getting at one position and two position. These are the minterms 0, 1, 2, 3. So we'll put 1 here. Now no combinations no combinations are possible in this case, so we will take it as individually. So we'll find that s is equals to here the value of A is equals to 0, so we'll take as A bar, and value of B is 1, so A bar B, plus here again value of A is equals to 1, so we will take it as A, and value of B is equals to 0. So we will take it as B bar. So the equation is A bar B plus A B bar, which is the equation of XOR gate. So the expression, Boolean expression for sum is equals to A XOR B. Same case for, we will solve for carry. Now we can see the value. We can see the output for carry we are getting only at third position. So we will put 1 here, and there is no other one for the combination. So carry is equals to here the value of A. value of A is equals to 1. So we will take it as A, and value of B is also equals to 1. So carry is equals to A dot B. So in this case, we are getting sum is equals to A XOR B and carry is equals to AB. Now, plotting these equations using basic logic gates, we will find the logic diagram for half adder. Here we are XORing A and B. So you are getting sum and joining the inputs through AND gate, you will get the carry output. Next is for full adder. So full adder is a combinational circuit which is used for the addition of 3 binary bits at a time. So again, 3 input variables will be there and 2 outputs will be there as sum and carry. So if you are having 3 input variables, so you will have 8 combinations. 2 to the power 3 is equals to 8. So 0, 1, 2, 3, 4, 5, 6, 7. So you are having 8 combinations. 0 plus 0 plus 0. Sum will be 0, carry will be 0. 0 plus 0, 0. 0 plus 1, 1. So sum will be 1, carry will be 0. 0 plus 1, 1. 1 plus 0, 1. So sum will be 1, carry will be 0. 0 plus 1, 1. 1 plus 1, 0 with a carry 1. So here you are getting 1 carry, but your sum will equals to 0. Now 1 plus 0, 1. 1 plus 0, 1. Sum is equals to 1 and carry is 0. 1 plus 0, 1. 1 plus 1, 0 with a carry 1. 1 plus 1, 0 with a carry 1. So here carry is 1 and sum is equals to 0. Now 1 plus 1 plus 1. Sum is also equals to 0 and carry is also equals to 0. So here you are having 8 combinations and 3 input variables are there. So you will utilize 3 variable K-map to solve the equations for sum and carry. So on solving the equations for sum and carry, you will get the equation sum is equals to A XOR B XOR C and carry is equals to AB dot BC dot AC in. So on plotting the equations using basic logic gates, you will find out the full adder diagram, full adder circuit by plotting these equations.